So hi friends, welcome to our YouTube channel A-OneTutors. We're here to assist you in your academic journey by clearing doubts and misconceptions. Please do support us by subscribing to our channel. If you have doubts related to this topic, you're in the right place. Let's get started without further ado. So, as you see, our today's topic is scientific notations, always written in the form a multiplied by 10 raised to the power b. Now as you see, as mentioned, a is the coefficient and b is the exponent. Now let's get down to some questions, as this concept in and itself is a very easy topic and you won't find any difficulty understanding it. Now let's get down to the questions. The question asks us to convert 42,515 in two significant digits. Now before being able to actually solve these type of questions, one must know what significant digits actually mean. Let's read them out. All digits following a whole number are considered as significant digits. Now the number here is 43 point, and then we have 3 trailing zeros after 43 as a whole number. Now according to the definition provided, we would consider these 3 zeros also to be significant digits. That will result me in having 5 significant digits in total. Now it's not necessary that the number has to be a whole number. It could be a whole specific value saying 43,000, not 43.00. Still the number of significant digits would be 5 significant digits. Now some people would ask me, now why is that? The reason behind that is the definition of significant digits also says that the number of trailing zeros after a non-zero number is also considered to be as significant digits. Now in that specific case, this also holds true. Let's read out second one. The second part says all digits are significant except for preceding zeros. Now the number here mentioned is 43 and then we have 3 zeros before that. According to the definition, it says the numbers before a non-zero number won't be considered as significant digit. Due to that, we have 2 significant digits as a whole in this specific example. Now a very obvious question arises that why do we use significant digits then? The reason behind us using significant digits is the more significant digits we use, the more accurate our measurement or the answer gets. Considering that point, there's a one more note to be made. So the note says the zeros between a non-zero number are also significant digits. Let's look at this example. For instance, the number says the zeros between 24 and 7 is also considered as significant digits. Now if we count the number of digits that it's happened to have is 1, 2, 3, 4, 5, 6 and 7. That's why we have 7 significant digits. And without further ado, let's get down to some questions. Now the first question that is to be focused on says 3405. Now the number 3405 has 4 significant digits. That's why the number that's mentioned here is 4. The number 500.05 has 5 significant digits. Thus 5 significant digits is the answer. The number 1,000,004 has 7 significant digits. The number 56 has 2 significant digits. And here's a tricky one. 5.0987 multiplied by 10 raised to the power minus 4 would be then simplified under this value, which gives us 0.00050987. And if we consider the total number of significant digits that we get, it will be 5. Now, being able to understand these questions was only possible if we read these notes thoroughly, and understanding the examples would help you understand the questions in a much better way. So if you still didn't get why I did this, please rewind the video and understand what was the concept behind it. So here's the interesting part, the conversion of number in scientific notation. the number here are the same as that we skipped earlier because we didn't understand what significant digits actually were. Let's read the question one more time. 42,515 is to be converted in two significant digits. And the second question implies the same, saying 137 with 4 trailing zeros before that non-zero number is to be also converted under two significant digits. Now, before trying to actually solve these questions, we'll understand this with two different examples exemplifying the same thing to get a better clarity on how to solve these type of questions. So let's begin. Before starting to solve these questions, let's read what's highlighted. The number after the wall must be greater than or equal to 5. Now, why does it say that? Let's start the question first, and throughout the process, I'll be explaining you each and every detail that you need to know for being able to solve these type of questions. So let's begin. Now they're asking 53,987 is to be converted in three significant digits. For being able to do so, as we only require three significant digits, so what we'll start from the leftmost side and count three numbers. So the three numbers that we see are 5, 3, and 9, and then we stop by creating a wall. Now what the wall actually does is it segregates the significant digits that I actually need and the significant digits that I don't need. The digits that I need are 5, 3 and 9 and not 8 and 7. But apart from that, I might also need 8. Now some people would say, why 8? Because we are not considering these two numbers as 3 is what we need. Now the reason behind that is it allows me to add number 1 to the number that is just preceding to the wall. So the number that's preceding to the wall is 9, and because it is greater than equal to 5, it will allow me to add 1 to 9. That will result in me having to have 0 at my units place, because 1 plus 9 is 10 as mentioned here, which will result me in adding 1 to 3, that will be 4, and then the whole number will become 540 segregated by 8 and 7. Now it's not that we don't include these two numbers, we do them, but when we convert this into scientific notation, we assume these as zeros and nothing else. So let's convert them into scientific notation. So this is what it actually would look like. Converting this into scientific notation would result in, as these are the number of significant digits that we need, we will consider only 3 of the values that were needed, and then 10 raised to the power. Now let's see where we would actually end up. So that will be 1, 2, 3 and 4. So that will be your answer under significant digits. That's how you solve this question. Now let's get to the second one. Second question asks us to convert 628 in one significant digit. Now how is this possible? Let's try and do this. For that matter of fact, I will start from left hand side and start counting on. Now when I start counting on, I see 6 is the significant digit that I need. So the rest of the numbers which are to the right hand side of the wall will be considered as 0. In that case scenario, when I convert this into scientific notation, the only number that I'll consider, which is before the multiplication sign, is 6. That will be multiplied with 10 raised to the power 2, as this is the place where the point lands as I start counting 1 and 2. Now this is the scientific notation, and as we've solved the two questions, now we'll be at a better place for solving two questions that are provided us at the top. Now let's solve these questions. The question says 42,515 is to be converted to two sig digs, which is significant digits. It's just an abbreviation which you can always try saying when you're well familiar with the concept. So it says 2. So I would create a wall right over here, starting from the left hand side and start counting on. I get to this point where I create the wall. Now what will that do is, then I'll have to read the definition again. Number after the wall must be greater than or equal to 5. If the number after the wall is greater than or equal to 5, then I'll be able to add 1 right over here. As it satisfies the condition, then I'll be able to add 1 here. So that will result in 43 here. Now as I'm done using them, I'll consider these all as similar to 0, nothing other than that. So let's write this down. Now converting this into scientific notation would be 4.3 multiplied by 10 raised to the power. Let's see where the point actually lands. 1, 2, 3, 4. This is where the point lands. That's why the exponential value that we have is 4. Let's get down to this one. The number is 137 and is to be converted to 2 significant digits with 4 trailing zeros preceding the non-zero number. Now if we follow the concept, read the definition, we get to the conclusion where we end here and we create our wall just beside 7 and 3. Now what that will let me do is I'll have 1.3. For that matter of fact, I'll be able to add 1 to 3, that will be 4, right? As it satisfies the condition, as 7 is greater than and equal to 5. Satisfies the condition, because of which I'm able to add 1 to 3. So as we know, this will become 1.4 multiplied by 10 raised to the power. Now if I see, I have 4 trailing zeros preceding the non-zero number. Now here's a trick. Whenever you're asked to have a negative exponential value, we'll always consider the number of zeros before it, and also the 0 before the decimal point. So the zeros here that we see are 1, 2, 3 and 4. Here's your final answer. Surprise, you got a new trick to solve these type of questions, and they're very much easier than you actually think. So stay tuned with our channel. We'll be there with some exciting videos like these, and that will help you exceptionally well in your academic prowess. Thank you so much.